I like to utilize a lab that I call Bouncing the Ball in my class that actually models the PDCA loop, the Deming cycle, and helps the attendees understand all the principles and issues that we just talked about. The goal is to maximize ball throughput across the team. The ball must be caught and thrown, hard and fast. Caught and thrown by everybody on the team to count as 1 point. You cannot leave people out of this game, right? We don't blame people for our process problems, agreed? So that means if I have 5 people on the team, all 5 people at the touch get a single point, right? 2 people cannot touch the ball at the same time. For some reason, these balls have some magic in them that if 2 people touch it, the magic drains away and it's gone, okay? So there must be an air gap between people, agreed? 2 people cannot touch it simultaneously, okay? Each full circuit around the entire team counts for a complete point. Each individual person is 1/100th of a point. So let's say it goes, 1, 2, 3, 4, and back to me, there's 1 point. And then 101, 102, 103, 104, 2.0. That's how we score. Very simple system, right? If you drop the ball, you have to return to the very beginning. So if it's 1, 101, 102, ouch. It goes back to me and it's 1-0 again. 101, 102 again. You cannot do a crappy job quick enough to win in this game, okay? You must pay attention to quality. Make sense? There's a penalty for not having good quality, okay? And in order to reduce the chaos, I want you to bounce the ball at least once on the floor before going to the next person. So catch the ball, you can bounce it, throw it to the next person, or you can bounce it to the next person. You guys figure out how to do it. It really helps to illustrate how even when people have been given permission to improve things, they often get stuck with inertia, or they show that they're afraid to really challenge existing processes and rules. 2, 1, start. "15 seconds. 10 seconds. 5, 4, 3, 2, 1. Hold the ball.
9.
Okay. Sharks, what you got?
9.
9.0, 9.01, what you got?
9.0.
9.0. How many defects? How many bobbles? How many mistakes?
No mistake.
0.
0 mistake.
Good. Jets.
10.1.
How many mistakes?
1.
Wow, that's pretty good. Okay, so let me ask you guys a theoretical process question. If I asked you to do the exact same exercise again and don't change a thing, would your velocity be the same, lower, or higher? What do you think?
Probably about the same.
About the same?
In theory, it would be the same.
Okay, I think actually since that was your first time, I think it should be a little bit faster. So every process has a maximum theoretical velocity. So as you start a process and adapt to it, the curve looks kind of like this, right? It looks, I'll draw it over here so we can see it on the board. So in other words, the process curve looks kind of like this, right? And this is the theoretical maximum from here, like almost like a limit in calculus. Would you agree? And so you'll quickly ramp up, and then the more you do it, you kind of get it grouped down, and your rate of increase or improvement will be slower and slower to approach that theoretical maximum velocity given a current process. Would you agree with that? Think about that in terms of your current process at your organization. If you've been doing it for any length of time, you've probably gotten pretty good at it. Agree? Even if it's not an optimal process, you're probably getting close to the theoretical maximum given that process, right? So let's try an experiment. Let's do the exact same. Don't make any changes to your process. Let's just run it again and see what happens. Are you ready? I'll give you a 5-second heads up. 5, 4, 3, 2, 1, start.
Wait.
15 seconds. Uh-oh, expensive error. 10 seconds. 5, 4, 3, 2, 1. Hold the ball. Big mistakes kill both of you, huh? What'd you get there, Sharks?
11.
11?
11. 2 mistakes.
2 mistakes. Interesting. So I think you guys lost about 10 or 12 seconds there, didn't you, at least? This is
blocked by the other 2.
Yes.
I boxed him out.
So again, but you were probably on a pace to run, probably to get 11 or 12, and that's when if that bobble hadn't happened. Okay, and you guys had 2 errors which slowed you down, right? Okay.
I think you would have probably done better than your previous score. Not much better, but better. You guys had even with your one error, which is pretty, I saw somebody going under the table in here, you still got a 22% improvement in your velocity, didn't you? So as you see, you're kind of getting closer to that. But do you think you could double your velocity given the current process? Okay, so let's talk about that whole thing about the check act now. So we've run a thing twice. You understand the process pretty well. Let's step back and think about it again. Planning is about coming up with a hypothesis, right? So come up with a hypothesis that relates to velocity to process in your groups. Because I heard kind of the same thing, but you guys are in the solution space. Let me warn engineers and technical people generally. We all love to jump into solution space if we really have a problem to find, okay? And the reason if you jump to solution space too early, you constrain yourself from other possible solutions, which may be better solutions, right? So remember, seek to understand the problem before the solution space. So I heard some solutions around here, but what is the problem? What is preventing you from going faster that your solution will solve?
Mostly humans.
Yeah. So you guys are about passing faster, passing in front of the person. So what I'm hearing, so I'm hearing that either the rate at which the ball moves or the distance that it moves is affecting velocity. Is that a valid statement?
Yep.
Okay. So the rate or the distance that the ball moves. Let's take one of those factors. Just say the distance the ball moves in total is impacting the velocity. So if you guys were like 100 yards apart, would your velocity be higher or lower? Lower. You should really hum that sucker, wouldn't you? And if you were staying on top of each other, what would your velocity? Would it be higher than what you're doing now? If you're close together?
Closer, probably.
Could be.
To a point.
To a point.
Especially if you're
Okay.
down.
So can we come up with a general hypothesis, which is that velocity is inversely related to the distance the ball moves?
Sure.
Is that a good
Yep.
hypothesis? And so therefore, solutions should involve minimizing what the ball moves to increase velocity. Would you agree? You see why focusing on the problem helps you come up with a general principle solution. And there's many different solutions that would do that. So talk about solutions that meet that principle and see what you come up with. Do it independently. I'm going to give you a minute. Then we're going to
The
try
goal
this
for
exercise.
me is to have the attendees recognize that they're really not looking at what's going on, but instead they're just responding by rote. That there's a lot of obvious problems in their organization, just like there are in this exercise, that until they're really challenged and shaken, they won't do anything about.
45 seconds to come up with a process change.
Right.
Battery versus.
Right.
We were all just a squat, then when we used to drop.
30 seconds for your process. Try something out. Don't just try it, see if it actually is effective. Try it. 20 seconds. Try it, see if it works. You're stuck with what you have, so try it now. Try your process, see how it works.
I think it's neat to
15
watch this
seconds and we'll
exercise
start
as an
up.
observer because you start seeing the same patterns that you would see with a newly formed Scrum team. The Tuckman model of team formation happens. The forming, storming, norming, and performing, where at first, and usually the first iteration or two, everybody's very delicate and not wanting to hurt the attendees' feelings. And then after a few times through the cycle, and they start getting a little frustrated or another team does better, they start getting competitive. And then they start arguing with each other and about which is the best way to do this exercise, which is interesting because that's what happens in Scrum teams also. And then finally, they start bonding as a team. And I can notice that when they start going from that storming mode into the norming mode, is they stop challenging each other and they start challenging me, the instructor, or the rules and policies that I've given them. And that's what I want to see. And finally, I think the most interesting observation is when I see the light bulb come on in people's heads when they go, yes, why are we doing this when it obviously detracts from our ability to deliver, and yet we think we have to?